My dear students, our discussion today will be held on periodictable. Before going to that, I like to say a story. So you have 50 students in your class, in a section of your class. There are so many students. Some are, say, singers. They can sing very well. Some are football players. They can play very well. And some are reciters. They can recite very well. And some are very much studious, and some are very social students. So we can divide the students in so many groups. In some groups, singer, players, the reciters groups, the social worker groups, studious groups, etc. Then it will be very much convenient to analyze their characters. It is very much cumbersome to memorize the character of all the students individually, the 50 students in the class. But if we divide the players, if we divide the students in some groups, like 5 groups, singers, players, reciters, studious group, and social worker group, then it will be very much convenient to memorize the characteristics of the students, and it will be very, very easy to analyze their character. In the same way, the scientists wanted to make group of the elements because the characteristics of all the elements are different. At the time, there were 92 elements, and these 92 elements have different characters, different natures, different chemical properties, and it is very cumbersome, very difficult to memorize the character, memorize the properties of those elements. In the same way, as I have already stated regarding a student, the the scientists wanted to make group of all the elements. If they started thinking, if the 92 elements are divided in some groups following the similarity of their chemical properties, similarity of their nature, then it will be very much easier to memorize the groups than to memorize the individual elements. Considering this, they wanted to make some groups. It was first Joveriner who thought about the elements, and he gave a law which is known as Joveriner's law of triad. Law of triad. That is law of three. He took every three elements in a group, say lithium. Lithium has atomic mass 7, and then sodium has atomic mass 20, and then potassium atomic mass 39. They considered it as a triangle Li, Na, and K. If you see minutely, then you will see that the average of lithium and potassium, average atomic mass 7 plus 39 by 2 equal to 46 by 2, that is equal to 23. So lithium, the first element, has the atomic mass 7, and the third element potassium has the atomic mass 39, and the average of atomic masses of lithium and potassium is 23, that is equal to the atomic mass of sodium. And it was actually stated by Joverina that every three elements in a triad exhibit same and similar chemical properties, but the atomic mass of the middle element will be the average of the first atomic mass of first and third element. This is Roverina's law of triad. And Roverina was successful for making this group of three for a few elements like sodium, potassium, lithium, like chlorine, bromine, iodine, etc. And he was not successful for making a complete periodic table, but it was the first step which gave us the idea regarding preparation of a periodic table. Now the second scientist was Newland, the British scientist. Newland gave a law which is known as law of octet, law of octet or law of octet, etc. Octet means 8. In the classical songs, in Indian songs, there are 8 tones: sa, re, ga, ma, pa, dha, ni, sa, and sa. You see, sa is the repetition of sa. First one, this is the sa, and the 8th note is also sa. Sa, re, ga, ma, pa, dha, ni, sa. Sa is the repetition of sa. Similarly, Newland stated that as in the classical songs, the 8th note is the repetition of first note. If you start from re, re, ga, ma, pa, dha, ni, sa, re. Re is the repetition of re. Similarly, every 8th element will be the repetition of the first element. In his law, he stated, if we start from first element, after 8th element, in that case, in the classical song, the 8th tone is the repetition of first tone, but after 8th tone, repetition will be same. Say, in the Newland octave. Now we are familiar with atomic numbers, but at that time, at Newland's time or Roverina's time, this atomic number, that is structure of atom, was not invented. So without atomic number, they had to prepare this table or prepare these groups. Actually, in his table, say sodium, we know that sodium has atomic number 11, and then magnesium has atomic number 12. This has atomic number 11, but he, considering the atomic mass, he first took sodium, then magnesium 12, then aluminum has the atomic number 13, silicon has the atomic number 14, and then phosphorus has the atomic number 15, and sulfur has the atomic number 16, and then chlorine has the atomic number 17. Oh, 1, 2, 3, 4, 5, 6, 7. And atomic number 18 has atomic number 18. Now it was not included in the Newland octet. There is nowadays in the periodic table, there is an inert gas argon which has atomic number 18, but it was not included in the law of octet. And then atomic number 19 has potassium 19. So following this, 1, 2, 3, 4, 5, 6, 7, and 8. Following this, without the inert gas, these inert gases were not invented at the time. Mr. Scientist Newland, stated that every 8th element will be the repetition of the first element. So repetition of sodium will be seen in potassium. Similarly, in calcium has the atomic number 20. Repetition of magnesium will be seen in calcium. If you see, nowadays the modern periodic table has been invented. If you see, before sodium there is lithium has the atomic number 3, 3 to 11, 8. Lithium has the repetition in sodium, sodium has the repetition in potassium. If you see here aluminum 13, here was boron 5. So 5 plus 8, boron and aluminum are same. Beryllium has 12. Beryllium is 4. 4 plus 8, 12. Beryllium exhibits the same character of magnesium and magnesium exhibits the same character of calcium. So this is law of octet. What has been stated in law of octet? That the physical and chemical properties of the element are repeated at the 8th element starting from first element as the repetition is seen in the classical. And this is law of octet. But Newland was successful through his law of octet for making the table up to maximum 24th element, and he didn't go ahead. So a complete periodic table was not invented, was not prepared by Newland. So scientists wanted to think about the preparation of a complete periodic table. So before going to that, we have to know what is periodic table. Periodic table is a table. Periodic table is such a table in which in the groups, we will discuss about the groups and periods now. In some groups, the similarities of the properties, physical and chemical properties of the elements are shown, and considering the similarities of the physical and chemical properties, same elements or similar elements are arranged, are placed in same group, say lithium, sodium, potassium in same group, beryllium, magnesium, calcium in same group, boron, aluminium, scandium, etc. same group. And these groups, the elements in this group, members of this group exhibit the same property and similar properties, physical and chemical. And so it will be very much easy, it will be easier to memorize the group than to memorize the characteristics of individual elements. And then the scientists, after the invention of law of octet by Newland, the scientists wanted to know or wanted to prepare a complete periodic table. And finally, it was Mendeleev, Russian scientist, who was able to make a complete periodic table. And we will discuss about the Mendeleev periodic table later on. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.